Hello, welcome to Unit 6, Lesson 3. I'm Professor Blackman. In this lesson, we're going to be simplifying radical expressions. We're also going to multiply and divide them and then simplify them after applying the operations. Let's go ahead and get started. So when we're simplifying radicals, there's two methods that I like to show students. The first is the perfect square method. So using this square root of 216 x to the fifth, y to the third, we're going to break it into perfect squares. And so 216 is 36 times 6. So I put 36 here and 6 here. X to the fifth is x to the fourth times x. And y to the third is y squared times y. And so we know with square roots that we can split them up because when we multiply them, square root of a times square root of b equals square root of ab. So if we have square root of ab, then that equals square root of a times square root of b. And so then I can put this first one times this second square root, and then we can take the square root of everything that's underneath it, which is a perfect square, which is 6x squared y, and then what's left as not a perfect square goes inside as square root of 6xy. Another method that I taught while at high school was the jailbreak method. And the theory is it's twin day at your local jail. And if you have a twin, you get escape. So if we look at 216, break it down into 2 and 108, break it down into 2 and 54, break it down to 2 and 27, and 27 breaks into 3 and 9, and 9 breaks into 3 and 3. So 216 equals 2 times 2 times 2 times 3 times 3 times 3. So here's a set of twins, so a twin escapes. Here's a set of twins, so a twin escapes. And so on the outside, we now have a 6. Well, we can do the same thing with x to the fifth, which is x times x times x times x times x. So here is a pair of twins, and here's a pair of twins. They each escape. So we have an x squared on the outside. This one did not have a twin. Same thing like the 2 and the 3 did not have a twin, so they stayed locked in the box. And then with y to the third, that's y times y times y. So right here, a twin escapes. So that one escapes, and this one is left in the box. All right, now I will be using the perfect square method, but I like to show the jailbreak method as an option. All right, let's look at more examples. So 24, if we look at that, we need to find the perfect square that's in there. So 1, 4, 9, 16, 25. Okay, after 25, it's bigger than 24, so we can't use that. 16 times anything does not give you 24, but 4 does. So this is 4 times 6. So 4 times 6, square root of 4 is 2. So this becomes 2 root 6. Okay. Now to look at the 90. After 25 is 36, and 49, 8 is 64, 9 is 81, 10 is 100. And so all those are bigger than 90. So when we look at the list, the only one on here that's a multiple of 90 is 9. So that is 9 times 10. Square root of 9 is 3, so that's 3 root 10. Okay, let's look at 250, but 250 requires a triple because it's a cube. So we need to find the perfect cube. That's 125 times 2. Cube root of 125 is 5. So this becomes 5 cube root 2. Okay, looking at 180. 180 is 36 times 5. So 36 times 5. X to the fourth, well, that is a perfect square. So we'll put x to the fourth right there. And so then we get square root of 36 is 6. Square root of x to the fourth is x squared, because x squared times x squared gives you x to the fourth. 6 times 6 gives you 36. And what's left inside is a 5. All right, so now we need to find the fourth root of 243. And so the fourth root of 243, well, 243 is 3 to the 5th power. So 3 to the 4th power is 81. X to the 8, that divides by 4. Y to the 8th is our perfect squares. What's left, if you pulled the 81 out, 3, because 3 times 81 is 243, and y squared. So when we take the fourth root and apply that, 81, the fourth root of 81 is 3. X to the 8 divided by 8 becomes x squared. Y to the 8th is y squared. And what's left in the fourth root underneath is the 3y squared, because that was not a perfect to the 4th power. All right, let's look at 16 times 2 to give us 32. So that's 16, which is on our perfect squares list. A squared divides by 2, b does not. So then this gives us 4a as perfect squares, taking the square root of them. What's left is 2b. All right, let's look at some more examples. All right, so here we need to multiply. And so the rule, which I stated earlier, is if you have the same root times the same root, you just multiply what's underneath. So 15 times 6 gives us 90. And then we need to do this, and we did this on the previous slide, which is 9 times 10. So that is 3 root 10. So we have this cube root here. You can see both have the roots of 3. And so then we have 16 y to the 9th. And then we need to simplify that. 16 is 8 times 2, so the cube root of 8 times 2. And y to the 9th, 9 divides perfectly by 3, so all of it can go over here. And so we have the perfect root of 2y to the 3rd, leaving a cube root of 2. So if you look at these on number 3, you notice that we have one that's the 5th root, and we have one that's a square root. So there's that understood 2 that's right there. So because these aren't the same roots, we can't do what we did previously. So we're going to take and rewrite this as b to the power of 2 root of 5 times b to the power of 3 root of 2. And so now we can use those exponent rules that we've used in the past. So that's b to the 2/5 plus 3 over 2. And I'm going to do that math over here to work on the fractions. 2/5 plus 3 over 2. And we need the common denominator, which is 10. So times 2 gives us 4. Times 5 gives us 15. And so 4 plus 15 gives us 19 over 10. And so this would become b to the 19 over 10. Now it depends on your definition. Sometimes you would leave it like that. Or of course you could rewrite it as b to the 19th power and a root of 10. Okay, let's look at our next one. So these, you see that they are the same root. They're both a cube root. So when we multiply those out, that becomes cube root of s squared, and s to the fourth becomes s to the sixth. T to the fourth and t to the sixth becomes t to the 10th. And we can go ahead and split that into perfect cubes. So s to the 6 divides by 3 perfectly. T to the 9, and I'll put a t there because 9 and 1 would give us 10. So then this becomes s squared t to the third, and the cube root of t would be left on the inside. All right, let's look at some more examples. Okay, so here we have a quotient. We have a division going on right here, but what we can do with division is in this rule right here, you can see that if we have these same roots top and bottom, we can do this root over the entire thing. So we have the same root, so this can be written as 35q over 7q, and we can cancel out those q's, and 35 divided by 7 is 5, so this becomes square root of 5. Okay. Over here, same thing. These are both cube roots, so we're going to write cube root, and we're going to do 96 a to the 4 b squared over 12 a squared b. So now that we've rewritten it, let's go ahead and simplify everything in that root. So that would be the cube root. 96 divided by 12 is 8. A to the fourth divided by a squared is a squared, 4 minus 2. And b squared divided by b is b. All right, the only cube that's in there that's perfect is the 8, so we're going to pull that 8 out. And then on the inside, we'll have the cube root of a squared b, because neither one of those, 2 and 1, do not divide by 3. All right, let's look at another one. Okay, so here you can see that we have the cube root of top and bottom. A lot of times when this happens, then we apply the rule similarly, but we do the cube root of what's on top and what's on bottom. So if it's together, we usually separate. If it's separated, we put them together. As you see, 81 and 64 aren't going to divide out. And so cube root of 64 is 4. 81 is 3 and 27, and 27 is 3 and 9, 3 and 3. So 81 is 3 to the fourth. So if we have the cube root of 81, that's going to equal 3 cube root of 3. And then y to the fifth, cube root of y to the fifth, is going to equal cube root of y to the third times y squared. So that's y cube root y squared. So then putting that together, we have 3y on the outside and the cube root of 3y squared underneath the root. All right, let's look at another one. So this one's square root. So we're going to apply the square root to the top alone, y to the third, and square root of x to the fourth. All right, on the bottom, that gives us x squared, because 4 divided by 2. Square root of 25 is 5. Square root of y to the third is y square root of y. So y square root y. Because this is y, if it's on the inside, and y. So we have 3 y's there. All right, let's look at our last set of problems. All right, so we have the fifth root of 32x to the eighth, and the fifth root of y to the 10th. So 10 divided by 5 gives you 2, so that's y squared on bottom. 32 is 2 and 16, 2 and 8, 2 and 4, 2 and 2. 1, 2, 3, 4, 5 2's. So that is 2 to the fifth. So 5 divided by 5 gives you 1, so that's 2. Bring that out. x to the 8, well, 5 of them divides by 5, but 3 would be left on the inside. So we have an x and the 5th root of x to the 3rd, because x to the 8th as a 5th root would be 5th root x to the 5th times x to the 3rd. So 5 divided by 5 is 1. That x comes out while the other 3 stay on the inside. All right, now we're doing 6th power. Okay, so we're going to write that as 6th root x to the 13, 6th root y to the 6th, z to the 12th. So on the bottom, those are perfect roots of 6. So 6 divided by 6 gives us y. Well, z to the 12 divided by 6 is z squared. And since we have 6 on top, we have x. 13 does not divide by 6, but 12 does. So 12 divided by 6 gives us 2. So we're going to pull out an x squared, and we'll have a 6th root stay on the inside of x. 2 times 6 is 12, plus 1 more gives you back 13. All right, that's all I have for you today. Happy studying.